In this video, we're going to talk about, again, the sines and cosine of special angles, those 30, 40, 60 degrees angles. And a spoiler, they are going to be the same as the values that we found in section 7.2. Yay! Let's begin. So here we have a triangle, an angle of 45 degrees. We also know this angle as pi over 4. And again, the sine is the x value, the y value. That's the sine, and the cosine is the x value of that angle. Okay, so what are the coordinates here? So we want to know. Well, again, this angle, this triangle is inscribed in the unit circle. So this diagonal is 1. I mean, this radius is 1. It is also a line that basically bisects quadrant 1 into 2 equal parts, right? So this angle is 45, so is this angle. It's also 45 degrees. So this radius is on a diagonal line that goes through 0, 0, through the origin. So here's this diagonal line, and the equation of this line is y equals x. So for any point on this line, the x coordinate equals to y coordinate and vice versa. So here we have that this x actually equals y. Now from the Pythagorean theorem, we know that the sine squared t plus cosine squared t equals 1, right? So therefore, we have x squared t plus, oh, there is no t, just x squared, because it's a coordinate of the points, plus y squared t equals 1, right? But we also know that y is same as x, so we could replace it with x squared, and that will still equal to 1. So we have 2x squareds that equal to 1. Dividing both sides by 2 gives us x squared equals 1/2. So now we need to unsquare both sides, and so we actually separate the numerator and the denominator. That's 1 over square root of 2. But remember, our rationalizing denominators, we cannot leave the roots in the denominator, so we have to multiply the bottom and the top by the square root. So our final answer is square root of 2 over 2. Okay, so our x equals square root of 2 over 2. So therefore, the cosine of 45 degrees equals square root of 2 over 2. Now the question is, what is a sine? Well, here it is. X equals y, right? So y is also equals square root of 2 over 2, and that means that the sine of 45 degrees is also square root of 2 over 2. Well, we did know that, right? We found it before in section 7.2. So this is nothing new. We just found it in a different way from this 45-degree triangle being inscribed in the unit circle. So what about a 30-degree angle? Okay, so this is my unit circle again, and 30-degree angle is about here. It's a third of my first quadrant. So we're gonna approach it the same way as we did before. I'm gonna actually draw another triangle here with 30 degrees. Now, both of these sides equal 1. And then if we look at, and also I'm gonna connect these 2 points. So if we look at this triangle, this angle is 60, and I have another 180 minus 60. That gives me 120 degrees to split between these two angles. So if I divide 120 by 2, that will give me 60 degrees. So each of these angles are 60. So I'm actually looking at an equilateral triangle. And what that tells me is that this side is also 1. This means that half of this side must be a half, 1/2. Okay, so now I know there is a right angle there, and I could use my Pythagorean identity to find the y coordinate, I mean the x coordinate um, of this point, which corresponds to the length of this side of the triangle. Okay, so this is what I'm looking for. This is my x, and this was my y. Okay, so by looking at this triangle, I have one leg squared plus my unknown squared equals the hypotenuse squared, 1 squared. So I'm going to have 1/4 plus x squared equals 1. So x squared equals 1 minus 1/4, which will give me 3/4. And then in order to find x, I need to unsquare, all of this, and get a square root of 3/4. Now, in order to simplify this, I'm gonna again break my square root and evaluate the numerator and denominator separately. So cube root of 3 just stays as cube root of 3. I mean, not cube root, square root. And the square root of 4 becomes a 2. So that's my answer. And the x coordinate, just like we mentioned, it actually is same as cosine of the angle. So cosine of 30 degrees is square root of 3/2, while the sine is 1/2. And sine of 30 degree is 1/2. Okay, guys, so this theme will be repeated over and over again. So you just have to memorize it. These function values for cosine 30, sine 30, cosine 45, sine 45, as well as sine and cosine of 60, the basic values that need to be memorized. Now let's figure out again the function values of the 60-degree angle. So here's my 60-degree angle. And what I'm going to do, I'm going to look at this angle this way. We're going to use the same rationale as before. We know that this is this side of the triangle is 1 and this side of the triangle is 1. So this is a uh, we have same sides. So that means that the angles from across those sides are also the same, and it leaves, since this angle is 60, it leaves 120 for the other two angles. Split them in two, you have 60 and 60. So we are looking at an isosceles triangle with all equal sides of 1. So moving on to the next slide. We know that this side is 1 because it's a radius of the unit circle. This side is a 1 also. So, and this side must be 1 also because it is an equilateral. I mean, isosceles triangle. So when we put a line perpendicular to our x-axis, it will split the x-axis into two equal parts of length 1/2 and 1/2. So when you look at this triangle right here, you know that one side is 1/2, another side is 1. So first of all, we know that the x-coordinate of this point right here is actually 1/2. Let's find the y-coordinate, which corresponds to the length of this side. Using Pythagorean theorem now, we have 1/2 squared plus y squared equals 1 squared, or 1/4 plus y squared equals 1, or y equals 1 minus a quarter is 3/4. This is y squared. And then when we unsquare it, so y squared is 3/4. When we unsquare it to get just y by itself, this is going to be square root of 3 over the square root of 4, or just square root of 3 over 2. So the y, or the cosine of 60 degrees, is also square root of 3 over 2. Here we go. And so what do we see? Let's summarize what we found in this section. So these are our commonly used angles, 30, 45, 60. And 45 has a sine and cosine that equals to square root of 2 over 2. And now if you look at the sine and cosines for 60, for the 30 and 60 degrees, they are switched around. Square root of 3 over 2 is a cosine for 30. At the same time, it's a sine function for 60, and vice versa. 1/2 is the cosine function for 60 and a sine function for 30. All right, so, but we knew that, right? Remember we were saying before that the about when we were talking about cofunctions, and we said that sine of t equals to cosine of 90 minus t, and same for cosine. So if we are talking about the 30-degree angle, right? So this equals to the cosine of 90 minus 30. And what's 90 minus 30? That's actually 60. All right, so sine of 30 is the same as cosine of 60. So same goes for the cosine. cosine of t is sine of 90 minus t, right? So in the case of 30, we have a sine of 90 minus 30, which gives us a sine of 60. So it works on both ways. And like I said, this all like ties together everything that we talked about before. Now, let's briefly talk about how to use calculator. We're gonna learn how to use calculator here. And it says, using calculator, evaluate cosine of 5 pi over 3. So first of all, what the first thing that you need to figure out is that make sure that your calculator is in the correct mode. So if you're using radians, make sure it's in radian mode. If you're using degrees, make sure it's in the degree mode. And here you have a button called mode. So take a look. Right now it's in degree mode. So we need to switch it to radians. So use the arrows to highlight what you need and enter. So now it's in radians. So quit this window. Now we can use radians. And on this calculator, your trig functions are right here. Your sine is here, your cosine is here. So we need to calculate the cosine of 5 pi over 3. So I'm going to press cosine. The parenthesis opens automatically. 5 times pi is right here, divided by 3, and that's it. And it gives you, the nice thing about this calculator, that it gives you fraction first, and then if you want to convert it into decimal, then you can do that by pressing this button right here. But if not, you can keep it as a fraction, and if you have a square root of 3, it will give you square root of 3. Pi sometimes gives you as a decimal, sometimes it gives you as a pi. So 1/2. Now go ahead and practice using your calculator and evaluate sine of pi over 3. And I know that you know what this value is going to be by now, but just for the sake of it, practice using calculator. And I know that this video is getting too long, so we're going to talk about domain and range in the next one.